Hello and welcome to the Cloud Chronicles. This is a very special edition. We're in our series on Azure Data Platform, and today we're going to be talking with a special guest, Bob Ward. I'll let him introduce himself in a second. I'm Joey Dantoni. I'm Principal Cloud Architect at 3Cloud. John, do you want to introduce yourself and hand off
Sure,
to Bob?
sure. I am John Morehouse. I'm a principal consultant with Denny Cherry and Associates Consulting. And Bob, take it away.
Yeah, I've heard about the Cloud Chronicles, kind of a famous show you two guys
Oh,
run.
Yeah.
So much. Thank you so much for inviting me to be on here. So I'm Bob Ward, a principal architect in the Azure Data team working on SQL. And it's kind of fun that you're talking about the history of things like SQL Azure because it's my 32nd year here at the company. And certainly I've seen this evolution between SQL on diskettes to SQL, eventually being in the cloud, and now SQL everywhere you can think, ground to cloud to fabric, right? So thanks for inviting me. Great to be on the show.
Was SQL ever on tape?
Well, we did backups on tape.
Yeah, like the first time I remember, you're a little bit older than us, but not much. And the first time I remember installing Oracle, it was on tape.
No, I
But
did Oracle installation. I did Oracle before I joined Microsoft, and I remember installing Oracle on tapes. No, SQL never went that path because those tape devices you're talking about are mostly on the Unix systems that you would go install the software. But yeah, SQL is just diskettes and CD and then DVDs, and of course now just all digital. So.
Well, we wanted to have you on because you wrote one of my favorite books about this topic because you talked about the history of it. I feel like we don't talk about everything in computing is always new, new, new. What's the latest? And we don't talk about how we got there enough because a lot of times we end up repeating the same mistakes. I'm sure you've seen that, John.
yep,
Yeah.
yep.
And I know because you read this chapter and we've talked about it a lot, you know a lot about the history of SQL Azure and how this all kind of came to be. And yes, for those of you who are new at this, we're calling it SQL Azure, which was the original public name of the product. Bob's going to talk a little bit more about that in a second. But can you
Yeah.
tell us about the very, very early days of Azure for both Windows and SQL?
Sure, thanks, Joey. I do like talking history of our product a little bit. I think you also, learn about obviously a lot about from the history of what you did. It is an interesting journey. I remember being an employee at Microsoft. I was in the support group, as you guys both know, for many, many years. And in 2006, I remember getting some internal emails as an employee, working a lot with the product team back then. This is Ted Coomer, David Campbell, some of those folks, Peter Carlin, getting an email saying, "Hey, we're going to go kind of go this venture of working on what we call a cloud database." I'm like, "What the heck's a cloud? What's a cloud?" Like nobody knew what that term meant back then. I remember getting this email about this. It's shortly after that, Bill Gates sent an email out to the all employees saying that we'd hire a gentleman named Ray Ozzie from IBM to come over and work on new cloud services for Microsoft in general. So what happened is back around 2006 is just kind of a time frame. So you think back in your head 2006, SQL Server dominated on what? Bare metal. There was no
Yeah.
even VMs were not a thing back then, right? And here we are talking about clouds. We're very skeptical, but I'm like, okay, we're going off on something. So kind of what happened was the SQL team started going down something on what we call the Cloud DB project.
Hmm.
2006. This is us thinking about how could we go maybe take SQL Server as a product and offer it and host it somehow in data centers that we may run, right, for databases. So we were down this path. At the same time, Ray Ozzie, you're going to find this story fun, brought back David Cutler back from the famous Windows NT days to come with him and discover could we do something for Windows. And one of the fun stories about that team was they named their project Red Dog. And the reason that came around, Buck Woody could also tell you about, he worked on these original projects, is they were down in California talking to the Hotmail team.
Hmm.
Hotmail was effectively a cloud email service right at the time,
Hmm.
Yeah,
right? Being service, being search. So they were down there to visit them and they saw some sort of place called the Pink Poodle. And so they said, hey, let's go name the project for Windows Azure Pink Poodle. And then they decided when they got back to Seattle, maybe that wouldn't kind of go over well. So hence somebody said, how about just Red Dog? Kind of a fun little side note of how they named their project. But we were actually working disjointly on these two things, not necessarily coordinating each other. We eventually started in 2008 at the Professional Developers Conference, PDC, by calling ours SQL Data Services.
Hmm.
But we still presented at the same time as they did as Windows Azure. So if you look at the original, and it's in my book, the original PowerPoint presentations, gosh, I found these things from way back. Windows Azure had SQL Data Services, with it there. And the thinking was really crazy back then. Let's do a cloud SQL server, and so forth. And I think Joey, you had a question you were going to ask me at one point, but I'll just tell you now is that David Campbell, I remember calling me saying, "Hey, do you think it'd be an issue if developers use REST to talk to SQL data services?" And I'm like, what do you mean REST? I know what REST is. Like, what are you talking about? Like a developer would use REST API to talk to a database? Yeah, that's what we're thinking. In fact, we're not going to allow TDS, endpoints to talk to this. And I remember talking to my colleagues, Robert Dorr and Keith Elmore at the time, and we were both just like, there's no way. There's no way any developer that is a SQL Server developer is going to do this, right? Isn't that irony, though?
Because 13 years later.
I think a REST approach might be pretty cool right now, actually, right? Which we do offer in some ways. But yeah, that was the original thinking. But then, because Windows Azure was the official name when it came out public in 2008, the thinking was, or 2010, let's call it SQL Azure. And that's where you see that blue mesh that you have and so forth. So yeah, the original was SQL Data Services, but now it became SQL Azure being the official name, along with Windows Azure being that official name to start with.
Wow. Yeah. It's cool history.
It's crazy stuff, yeah. But again, two different projects. It's different, right? But then these worlds came together when we kind of made these first announcements, for sure.
So what was like the early architecture of SQL Azure? What was the high availability? What was backup? And
Well, because of the fact we started separately, we actually worked on a framework called Autopilot. That was the name of think of it like the service fabric, right? Behind the scenes that SQL Azure was based on. That was not what Windows Azure was based on. So we decided to launch these things, but we were not effectively on the same architecture. So we had to build our own HA, our own type of infrastructure for failover, redundancy, networking, and so forth on this Autopilot system, whereas the Windows guys were on their own Windows Azure piece. This is the predecessor to Service Fabric inside Azure. So what we did was eventually we came up with this project called SAWA, SQL Azure on Windows Azure, and this was us pivoting our Autopilot architecture into Windows Azure. And now, again, nobody saw that necessarily, but behind the scenes, the Windows Azure team had all those services for HA and shared storage and networking and so forth. So we eventually made this merge to go over there. That was what we call the SAWA project, and that was a big deal, like 2012 timeframe. And it was really important because you had guys like Connor Cunningham spending a lot of time at this timeframe working with huge customers like Pottermore. I don't know if you remember. Pottermore was like a website for Harry Potter fans and so forth.
I came across them in your book chapter.
Yeah. Well, it's one of the biggest sites in the world to run websites at that point for Harry Potter fans. Think of that time frame, right? And they were running SQL Azure on it. So, Connor's got his incredible stories about doing that. But we needed to run on Windows Azure to make that all viable. So that was the early architectures of this. And that really exploded us a little bit because we were really hampered by this Autopilot infrastructure because we were having to manage it. Now we could focus more on the SQL aspects of the architecture and then rely on the Windows Azure team to support all the infrastructure pieces, supporting all our virtual machines and all that kind of type thing.
I'm trying to remember, in the early days, wasn't like transactional replication kind of used in lieu of like to provide the replicas?
We didn't use transactional replication. We used pieces of what is now always on availability groups, even early on, right? Even though, because remember that part of the software was already out in the world, or that came around 2012.
Yeah.
But early predecessors, database mirroring it around for all, right? So we already had log replica type facilities to send transaction log changes, but we didn't use transactional replication. We still had to use things like they're provided for mirroring to make these successful. But early on, you got to remember now, it was all shared storage architectures. There was no business critical, as you know today, behind the scenes. So if you think about shared storage, you don't have to send replicas of transaction changes. It's more like a cluster environment. So that's all we offered early on in those early days. But we still had to have things like failover. Now we had Windows failover clustering around for a while, as you remember, right? So the early architectures of Windows Azure failover all supported those kind of things, but there's things that we had to do to make it manageable at scale. That was one of the biggest things we had to do. Like we didn't feel like we could manage Windows failover cluster at scale. So we had to provide things within the actual data centers to make sure we could do it. But those early days of Windows Azure were all based on some, those architectures that you know and love today.
Yeah, that's really kind of interesting. Like I knew because there were a lot of one of the things I really remember. I was fortunate enough to have worked on SQL Azure kind of from the beginning. John, do you remember? Weren't there like a lot of data type limitations and such?
There was, I recall, and I had a client way back when that started that wanted to do a project. They actually processed pig GNA or DNA, excuse me, and they wanted to use the early iterations of Azure SQL, and there was a limitation though, a size limitation, if I remember right. It was like what, 10 gigs?
It was very small.
It was small.
Yeah.
It was really small.
Yeah.
And so they,
Well, you got to remember too. Also, we didn't. Azure itself didn't have many data centers.
Yeah.
We're not talking about this incredible footprint we have today. Everything was like in Seattle. There was very few data centers out of the gate that we had. Eventually, that got expanded, but limited amounts of capacity. We still had not really cut our teeth on how to run this at a very cost scale operation. Do you know what I mean? Like making it very prohibitive for us to do things at scale that are cost available for us, right? I mean, the things that could run at cost of goods sale. So we were still trying to figure all that out as a company as well, which is why we had to limit some of this stuff. Like, how do we do this at a really large scale?
So you mentioned like early on, like shared storage, and it was the start. Like, how did you handle like noisy neighbor type stuff? Like,
Yeah, it's funny you mentioned that because that was, so again, remember, we go to this SQL and Windows Azure type scenario, but at the time, the architecture at that time was still SQL. We had to serve SQL Server instances. This is still the engine that you know and love, right? But what we did is for each customer, we still hosted different customers on the same SQL Server instance. And then we had to figure out, you think about those days, customers are trying to figure out how to go do virtual machines were starting to become popular. And it's all about consolidation. So you think about us doing SQL at scale in our clouds, we had to figure this project out. How do we do consolidation to make this all viable for us? But in the beginning, our original architectures, many different databases for customers could be hosted in the same instance. Now we isolated to make sure you couldn't see anybody else's data, but performance was an issue, right? So what came along was this concept called Project Sterling. This project came along around 2013-ish timeframe. The funny story there is from Peter Carlin. I asked Peter Carlin, original architects on SQL Azure, why'd you call it Sterling? Sterling. Is that like a bird? Like, what is this thing, right? Bird. Well, the funny thing is, it's not. There was a gentleman named Robert Sterling who created this really efficient heat engine system as an engineer. And his name was pronounced or spelled Stirling. Somebody mispronounced this in an email to announce the project. Well, you know how things go, right? Nobody corrected it. So the name Sterling came from this engineer who built a very efficient engine, but it was supposed to be Stirling. But here's the thing. What happened was, we call it V12 of Azure SQL. Do you guys remember that? V12 project? Okay. Think about at the time, this is SQL 2014 timeframe, right before we launched 14. The version number of 14 was 12. So if you go look today, what does the AT version tell you about Azure?
12.2000.
Yeah.
That's where we baked it. So version 12 was the big moment, and there's a couple things that happened. Number one, we went off and said, okay, everybody gets their own instance for the most part, unless you were like a really basic DTU. So we made sure we isolated people on different instances, even though you had a single database. But we figured out how to go do that at scale in a very consolidated way. Because remember, we support multi-instance in SQL Server.
Yeah.
So that's number one thing we did, is move to that kind of architecture. We also brought in this whole idea of logical servers, which allowed you to kind of have this like metadata across many different databases. And the biggest thing we did that took forever is to merge the code bases, like to get because at that time we had really forked off the code base of SQL Azure and SQL Server. So we had to bring the code bases back together into this main branch, because we knew if we're going to go at scale in the future, we could not do this. We had to have one code branch that we could use for both the cloud and on premises. So what I call the Sterling project, or V12, was really a massive moment to make. And at that same time, changing the name to Azure SQL Database all kind of came together in that, I think it's about 2014-ish timeframe. So that's how we got rid of noisy neighbor, and that's how we got moved to a architecture that we felt could support, databases at a much larger scale.
Yeah, I feel like that was about when everything got a little bit more mature.
It was tough though. That was like a multi-year project for them to bring the code bases together.
Yeah.
Move to this instance model. And remember the tough thing we had to do. We had to migrate people behind the scenes to these things. I remember seeing these emails saying, hey, everybody, congratulations, autopilot's over, or hey, congratulations, they call the Sterling project Sawa V2. Hey, we've got everybody in Sawa V2 now. Hey, we're all excited now, right? So, but we had to do this because our customers can't know we're doing this. Now, they saw the V12 because, from a customer perspective, provision new database, it looked different. So they kind of had a little feeling from a customer perspective, but we try to make this as seamless as possible behind the scenes.
Yeah, I remember there being like there was like an opt-in switch to upgrade to that. I think you could
Yes.
select in manually.
That too.
That's one you had to kind of opt into because we just couldn't make it. But that opt-in had to be fairly online. It couldn't be like it took like days or something, right? So we had to kind of think towards those levels.
So is Azure SQL Data, because Windows Azure kind of doesn't really exist, is Azure SQL Database the longest standing Azure cloud service?
Yeah, it's funny you mentioned that. So, if you think about that time frame too, this is what, let's think about this. 2014 or so, a couple things happened. Number one, I don't know if you remember this or not, but Satya Nadella, who our CEO is today, he took over what we call the server and tools business, which Scott Guthrie runs today. We renamed that whole division, right? The first thing Satya did is bring IaaS into play. At that time, we did not have IaaS. Didn't that sound crazy? We had something called Cloud Service back then, which was the ability to run like a web service, but there was no storage. So SQL can't run in that aspect. So one thing Satya did is light up IaaS. So SQL became a big player there, right? That's a big deal. A little after that time, Linux became a thing. So somebody said, we can't be Windows Azure anymore. We need to be Microsoft Azure. But you're right. If you go back and look at the original diagrams of Windows Azure and Azure, besides just running what you see today as Azure App Service, SQL and Azure App Service, the predecessor of that was like web services, cloud services, were the two longest standing services in Azure. There's no question. So you think back now, what is that, 2008? We first started now. And so here we are 17 years later, right?
Rusinovich said at MVP Summit it was the 15th birthday of Azure. So I guess they're officially calling it 2010.
That's true because we didn't really go public. So we announced it in 2008, but in 2010 is when we actually launched it for you to actually use as a public service. Yeah. So we had people doing private previews and looking at it back in those days, 2008, 2010. But 10 was the launch officially of Windows Azure.
Yeah.
Wild.
Yeah.
I know.
Yeah, it's crazy.
The addition of the V12, I think, is really cool.
Yeah.
It was a pivotal moment. It was a big deal. I remember being in these big discussions about how we're going to support it and so forth. And if we did not make that move, we could not be where we are today for sure. But I think the decision was at that time to rebrand it as Azure SQL Database at that same time. So even though we did IaaS, we had the database concept. But it's funny, if you ever talk to Connor, he refuses to change his calling it SQL Azure for him, man. He'll always call it SQL Azure.
SQL Azure was such a good name. But
he was a huge part of this. I mean, you think about what he did. He was a major architect for us, but he also was major and instrumental in getting these big customers signed up to use these things. So he had such a practical insight into what was going on with our customers and gave us insight on how to go make the architecture successful.
Yeah, it's been so interesting to kind of see it feels like Azure SQL Database has really matured just alongside of Azure in general, but it's also been kind of on the front of a lot of things like Private Link and some of the other Defender features that are kind of baked into the solution.
Well, we call it a Ring Zero service. So if we launch a data center for Azure, Azure Database is always there. Like it's not even a question. It's like a first-party service that it has to always be there, and it's still one of the most popular services across all of Azure, and the most popular PaaS type service, right? But part of that also is interesting because the Azure platform team now has always told us same thing goes back is we learn from each other. So when they think about trying to go make improvements in Azure, they're always asking us, okay, well, how's Azure SQL Database going to operate, right? The same thing applies to Windows Server and SQL Server, about that journey together as a workload being on Windows Server. Same thing is applied in the platform, the cloud.
So Joey and I have had like many conversations that Azure SQL Database is probably one of our most favorite features. I recommend it to pretty much all my clients for new work. Like, when do you think that transition happened for enterprises to actually look at Azure SQL Database as a solution?
Sterling helped, right? Because Noisy Neighbor was just killing everybody. I mean, you just can't run a predictable performance is huge, right? I think Hyperscale probably changed the game the biggest.
I'd agree.
Now,
Yeah,
now
that's
I
a big
think
thing.
there's a couple things before hyperscale. Number one, this DTU licensing model that that is still today,
Mhm.
we started offering a vCore model, right? I think that was a big deal, and also introducing business critical because
Mhm.
business critical gave you a IO performance latency you just didn't have from that shared storage model. Plus, we started using availability groups within it. So
Mhm.
introducing vCore and business critical, that helped us a bunch, John. Like really trying to get enterprise customers to say, okay, I can actually run now a high speed latency workload. But I think hyperscale also is a major game changer. The team, it's interesting that the name of that project, I love these project names, right? That was called Project Socrates. And I
Yeah.
asked one of the architects, like, why'd you call it Socrates? I always ask him, like, why'd you call these names? And he said, well, he was in the room with the giants of SQL, Hanema and David Campbell and all these people talking about this new architecture, Rohan Kumar. And if you think about the concept of Socrates and critical thinking, he kind of was like this like lightweight person with all these giants doing critical thinking. So he came up with the name. Now let's just call it Socrates. But that idea of trying to run in a cloud service something at really massive scale, hundreds of terabytes, was not something we could achieve with where we were, with what you now as general purpose today, even business critical. So I would say hyperscale was that moment in time where really large enterprises said, okay, I can go now run a 20 terabyte database and do it at a really large scale without paying bukus of money. That was a pivotal moment for us.
Can you
And
talk a little bit about how hyperscale works? Because I think something that a lot of people don't understand is how it's a really unique architecture that you can really only do in the cloud. And most importantly, to your cost point, it disaggregates storage and compute cost,
yeah,
which, yeah.
Well, if you think about it, let's say you're going to run a 20 terabyte database and you guys deploy these yourself today, right? Like, how are you going to do that and have all the memory resources to do
Spend a
this?
whole lot on a VM.
Yeah, you'll have this massive machine or VM, right?
Yeah,
So the
yeah.
only way to make this work, right, without having to do that, is to separate a few things. First of all, separate the storage itself of the database. And if it's going to be that large of a size, you have to actually put the actual database files on something that is not expensive and something that you can back up and store quickly, right? So we picked Azure Storage for that reason to be the database itself. But you need a distributed architecture.
Mhm.
So, and then you can't have it all in RAM. So how do you do that? Well, you build in these concept called page servers. So in the middle of the actual compute, which is where your database sits and your SQL server sits, is a set of SQL servers that can effectively just fetch pages as you need, but quicker than going after the cheap storage, right?
Mhm.
And those are SQL servers that have their own buffer pool. And then in the compute layer itself, there's actually a buffer pool extension concept, right? Where we can go after a local SSD to pull in pages. So if you think about it, I got to get a page for an application, right?
Mhm.
I'm going to go in my buffer pool first at compute. Maybe I'll go to my local SSD drive. And if not, I'll go to my page server. Getting the data from the cheap storage has to be very infrequent.
Mhm.
So I can't make this a viable app, right? So then I have to take that concept and scale it this way. Like if I want to get bigger and bigger, I have to have more page servers, more compute, and more, but the storage is still the same.
Mhm.
So let's create this layer and then scale it this way to get really, really large. And then you think about the shared storage part, Azure Storage. Well, it has the concept of snapshots already built in.
Mhm.
So that's why when we actually go in and have to restore a database, we can just restore snapshots and the diffs. And then the final piece is transaction logging. Like, how do we do that across this crazy architecture? So we had to introduce a new service in a way to
Mhm.
do remote transaction logging. I know that sounds kind of crazy, right? But that service has to be able to be the one to supply transaction log changes to support things like replicas or even point-in-time restores. So altogether, imagine you building that.
Mhm.
Like imagine you trying to go
yeah,
manage and build something like that,
no,
or us trying to have a SQL Server customer do that.
Mhm.
So well, how do you do it then? Well, the only way we can do it in the cloud is we know how to go manage all of those pieces at a really large scale for a bunch of customers, all using things like Service Fabric behind the scenes. So that's why. And here's the thing, though, we made a mistake calling it hyperscale, guys, and we still today all agree we should not have called.
Mhm.
I think so. I think you know why? Because even I tell customers today, you don't have to have 100 terabytes to
Yeah.
use this.
yeah, yeah,
We changed the pricing model a couple of years back now. So like effectively the licensing of the SQL isn't even part of the pricing model. You pay for compute and storage, and it has auto scale, serverless and so forth, right?
Mhm.
So I'm trying to tell my customers now, like, look, just start at hyperscale. You don't have to, it's not for 100 terabytes. But because it's called hyperscale, everybody thinks it's only for the largest workloads in the world. So, that's why I try to tell customers like, and in fact, if you go look at the portal now, it's very interesting. What's the default?
Hyperscale.
Hyperscale. if you pick the production option, right?
Yeah, and the other thing I try to always tell people is the transaction log throughput on a 2-core hyperscale instance or server or whatever we're calling those things is better than, like, I think until you get to like 16 cores of business critical, because it's 150 megabytes per second. It got upgraded at some point last fall from 120. So transaction log write throughput is the best on hyperscale unless you're spending a whole lot on business critical.
I mean, unless you're, a stock exchange, right? Type transactional level processing. We found Hyperscale to be perfect for these IO needs, right? Whether it's transaction logging or read scale or whatever it is, right? And that's the other thing we did is we tried to make sure that for read scale operations, this could be really nice. Add as many replicas as you need to scale that. But here's a misnomer about Hyperscale. You don't have to have any replicas.
Yep.
Because of the fact that the database is on shared storage, it's almost like general purpose with 0 replicas for like a failover environment. But if you want a more, quicker failover time, just add a replica, and then we can use that. What's interesting is we're not using always on availability groups to do this replication. We don't have to do that because the transaction log service is there. These replicas can consume these changes from the log service to keep the replicas up to date. So it's a really nice architecture, and I've shown the architecture, and you've seen me in presentations show it. In a way, like I feel like I'm doing a disservice to us to do that. It's like, I just want you to know that you can go build a database as small as you want and scale per your needs and just pay for your scale as you go. And that's really the way we should. If we had a chance, we would not have named it Hyperscale. Would have called it something else.
It's SQL Magic or something.
Yeah, the SQL Magic. There you go. The SQL Magic database. I don't know.
Yeah, one of the things you mentioned there was snapshots in Azure, and that was a feature that, believe it or not, made, I don't know if you remember this, made it to 2016, where you could store data files in Azure.
Yeah,
and snapshot them. I taught it in a training class once. I never saw anybody implement it until John and I saw it like last year at a client, and it didn't.
They don't realize that you can put your files
well
in Azure storage, and you got automatic snapshots, right? Because you're doing that, right? Exactly.
Yeah, their server was like in an on-prem data center, and their data files were in Azure.
In the cloud.
It didn't work very well.
No, it did not work very well.
That's a bad example, but can you point to some of or talk to some of the other features that really came out of Azure SQL and went into the box product? Because I think that's always a pretty interesting story, because I know you all have learned so much in managing SQL Server.
Yeah, it's interesting you say that, because if we did not have the cloud, the number one thing, I remember putting this in part of the book because I interviewed Rohan Kumar about this. If we did not have the cloud, I think we would still be in a pace where these SQL Server versions would even be farther away than they are today. Because the reason why is we learned the engineering system methodology behind the scenes to produce SQL servers very quickly. Connor used to tell me, if we wanted to, because of our engineering systems, we could produce a SQL Server version every month.
Holy smokes.
Exactly. And you're like, well, why don't you do that? Well, you have to have value for a major version of SQL Server. So, you're not going to want a SQL Server. There's been a debate. We've even talked to folks like yourself as MVP. Should we do a versionless SQL Server at some point, right? Because the engineering system on the scene, we had to get to a point, you can't survive as a cloud service if you're not iterating and innovating all the time, right? So the number one thing I would say is just the fact that the engineering systems were set up in a way that we could iterate and build this product and test it and put it out there very, very quickly. The other thing to do is just making fixes. Like, for SQL servers, I was back in the day in CSS, as you know, in SQL servers. So sometimes create a bug fix or something very complex took a long time.
Right.
You can't survive in the cloud that way. You have to do things at a much more rapid scale. So even putting in some of the automation to detect stack dumps and figure out what to go do based on those kind of type things. So it's funny you mentioned about features. I think of more in terms of what happened behind the scenes to produce and engineer a very high quality SQL server at a huge scale and at a rapid rate, whereas before we didn't have that with SQL Server itself. So even though we had gotten around, you saw SQL 12 and 14 and 16 and 17, to me, the ability to rapidly develop, to test, to engineer, to fix SQL Server behind the scenes is really the big thing that came out of what you see in SQL Server today.
Very, very cool.
Totally.
Yeah, I think
that blows my mind.
Yeah, it's really incredible, and just to see how it's kind of the cloud has evolved in general, and
Totally.
from the early days of the portal and not having any kind of private networking to having all this security, and It's just really impressive to see how everything has kind of evolved in sync.
It's funny you say this because, me being a presenter, I presented with both of you at many different events and so forth. I remember a day in 2000, I don't know, like let's take SQL Bits, a good example. I think it's 2012. I was there, 13 or something at one of the events, and I did a session on Azure, and I had like 5 people in the room. And then I did a session like 2 hours later on SQL 2012 troubleshooting, and people were like standing room only. Right? I would go to an event where they would say, you can come and present, but just don't talk about Azure. Because at the time, the thinking was we were just trying to push you to the cloud. I don't want to touch the cloud. And look at it today. I mean, look where you are today, right? Same thing happened with virtual machines. I think of the same type of evolution. And I see that happening with AI today. Same type of thing, right? Where people are like, I don't know. And then you saw what happened with the cloud. I think we're headed down that path again, where technology like that will be embraced at some point. We still have a lot of customers, guys, and you work with our customers and know that they're still not willing to go to the cloud or thinking about SQL in the cloud. And I totally get that for certain reasons why. But I don't have near conversations like that as I used to, where customers would outright just say to me, don't even bring this up. I don't even want to talk about that language. I don't care what your reasons are, or what your benefit is. Like, don't even ask me. That's a different conversation today.
Yeah, and I think back in those early days, there was such a gap.
There were gaps.
And that's what that's what we've kind of talked through here, is that gap really went away, and then it all made sense. Once the features were there and you saw the vision, it was just ideal.
I mean, one of the biggest projects that we did to remove gaps is managed instance. And the name of that project, by the way, was called Cloud Lifter. Did you know that was the name of that project?
I think so. Yeah.
I did not.
Well, what happened, guys, is that customers would say to us, like, okay, I need agent. I need transactional replication. I need resource governor. I need instance level features that we could not do in Azure SQL Database. And the reason why is because, again, even though behind the scenes an instance could host your database, we could not expose that entire instance, right, to everyone. Otherwise, we could not host these databases at this scale, right? So Cloud Lifter became the managed instance project, where we're like, let's go do a PaaS service that feels like a SQL Server instance with multiple databases. And that's kind of another thing, Joey, of that evolution of us saying, okay, well, you're saying you can't migrate. Well, how do we help you migrate? Well, let's go give you the instance concept, but let's do auto HA, auto backups, deployment, evergreen, all that kind of same stuff you go to database, but do it at the instance level.
Hey, John, I think this is where we're supposed to ask for our most requested feature in Azure SQL Database.
I thought it. I wasn't going to
Yeah, come on. Let's hear it.
Go ahead.
Oh, no, you want me to ask it?
Yeah, John, come on.
We want backup to Azure SQL Database, backup and restore.
You're the first person.
Restore.
John, you're the first person to ever ask me that.
Oh, I bet not.
Kidding.
I bet
Just
not.
kidding. I hear you. I know. I get it.
Yeah.
All right, Joey, what's yours?
It's the same thing.
Yeah.
Okay. Yeah. That's. It feels like every 6 months we meet with a PM, and every 6 months we see some new tool that's just a wrapper on how to export a backpack to Azure SQL Database, and we're like, yes, it still falls down for like a 500 gig or higher database.
I mean, what we hear from our customers is the same thing you're saying, right? Number one, I just want to get quicker into the cloud, like I came to do with MI and with VM, just to restore my backup. That's the number one thing. But number two is exit strategies. Like I want to be able to go take an actual backup from an Azure database and put it on-prem, because I have some compliance reason to require that. And of course, we support that with MI and in VM scenarios. So I'm not sure that's what you guys are thinking, but that's what I hear.
Yeah, that's especially with EU customers. I hear that one a little bit more. That one's a little bit more challenging. And I know the reason, if you're watching this and you don't know, the reason why, my understanding is the reason why we can't just back up into SQL Azure is the nature of the shared environment, and there's some minor security risks there, but that are a big concern.
And rightfully so.
It is absolutely the nature of the shared environment. It doesn't mean that we're not, creatively trying to think of a way to do it. But one thing so you can imagine, the one thing we can never compromise is the security of your data, right? And you would not believe the conversations that we go through internally about any feature we're going to offer up. We just announced data virtualization, by the way. Maybe you saw that for Azure SQL Database, Polybase, Parquet type scenarios. That took forever in Azure SQL Database, because if you think about what we're doing, we're going outside the engine to some location outside the engine to allow you to read data or even export data, right? So since we're going outside the engine in that shared environment, it's really different, because that shared environment is a different shared environment than managed instance. Managed instance has this concept called a cluster. It's like a ring. It's a different environment that we've set up for you as an instance, that gives us options to make those easier. But Azure SQL Database is not that environment. So this is why you see features like that just take a lot longer to kind of bring in there to make sure we don't violate any issues with security of your database.
Sure, and that's important.
Yeah. Well,
But we
Bob,
get it. But by the way, we know we know we have to do this at some point, right? So
yeah.
we get it.
Thank you so much, Bob, for your time.
Thank you
and
so much.
And we really enjoyed this conversation. I think our viewers are really going to enjoy it. So like and subscribe, and we'll be back to talk more about the various Azure Data Platform options in Azure.
Stay tuned.
Yeah, stay tuned. Thanks a lot, everyone.
Thanks.
Bye.
Thank you.